So, hi, my name is Mario Rodriguez Cantelar. I work at the Polytechnical University of Madrid, and I'm going to present the dataset preparation for training modern dialog systems. So, a brief overview, first of all. The main goals are to pre-process and to clean all the dataset that we want to use in the workshop. We also want to standardize and unify all the formats. Oops. I don't know why it's changed.
My fault. Sorry.
Okay, okay. And then we want to standardize and unify all the formats of the datasets and provide the scripts and tools to extract features that we need in the future from these datasets. We also want to translate the datasets from one language to another and also translate back to the original language in order to perform automatic quality analysis. I don't know why. Oh, okay. To save all the data of the workshop, we create two repositories. And the GitHub repository where we upload all the documentation, the pre-processing, the feature extraction and toolbox scripts, and also a wiki where we wrote all the identifiers and formats of the datasets. And also we have a S3 bucket from Amazon where we upload all the files that with the preprocessing dataset, the features extracted from datasets, and also a file registry where we write all the contents of the bucket. I think I lose the control. I don't know.
Okay, I think we're a little not so good, so please just tell me when to
Okay,
change.
thank you. So at the beginning of the workshop, we create a list, a collection of 15 different speech and text dataset, and we annotate in columns the different information of these datasets. So we have the language, the number of dialogues, the terms, the annotations. So we can't pre-process all these datasets, so we have to choose which one we want to process and extract features. So next slide. We decide to create sorry. Okay, we decide to create a criteria to decide what dataset to use. So we want to use only text dataset that has human and human chatbot conversation, and also have need to have annotations. So we ended up having 13 datasets. Next slide. And now I want to explain the preprocessing process. So we decide to use a multiple file system that contains 6 types of files. The source files contain the original dataset, then the read file and the general information. Then the main file has the raw text, the raw data, sorry. And it has 3 columns. The first one is an unique identifier for each utterance. Then it has the speaker identifier. And finally, in the last column, you have the utterance, the raw utterance, the text of the utterance. And also we have another columns. For example, if we want to extract tokens or times. We also have a metadata file where we save all the annotations that the original dataset has, the feature file where we save all the extracted information of the files, and finally the annotation file with the feature annotations that we made over the datasets. Next slide. So we create several scripts to extract features from these datasets. The first one allows us to extract linguistic features as lemma, parts of speech, toggle. Also, we can extract the entities. We can split the utterance in the different sentences. We can check the polarity if utterance is positive, is neutral or negative using the text block and Vader library. We also can calculate the novelty vector between one utterance and the next one. We can tokenize the utterance using the verb tokenizer. We can create an entity grid that contain the cross occurrence grid of entities across sentences, and also calculate the transition probability in this entity grid. Next slide. Okay. We also have a script to calculate the CBOW and scriptgram embeddings, the glove embeddings, the vector embeddings using the SPACY library. We can calculate contextual embeddings using any model of the Hugging Face library. We have a script for the and a specific script for the Roberta basic context embeddings. Then we calculate the cross-sentence similarity between the embeddings of the Roberta model. And finally, we have the natural language inferences course that allow us to calculate the contradiction, neutral, and enjoyment scores. Next slide. And finally, we have a script to classify the different utterances between 7 different emotions. And also, we use the Microsoft Azure Cognitive Services to translate text from one language to another to analyze the text. We extract the polarity of each utterance with this service, and also we can detect the toxicity in each utterance. Then finally, we have a script to correlate between features and annotations. So in order to calculate the Spearman, Pearson R, and Kendall Tau information. Next slide, please. So now I'm going to explain the toolbox. We developed a toolbox that works as follows. We upload all the files to the S3 bucket, and we also have a file registry of all the content of the S3 bucket. So using this toolbox, we can check and extract all the collections and the corpora inside the bucket. Next slide. So easily we can, for example, running this command line, collection.summary, we can check all the information of inside the corporas of the bucket, and easily we can extract the table below. As we can see, we have 13 datasets, around 2 million terms, 79 feature files, and 16 metadata files. Next. And also we can check the contents of the file registry. I mean, all the files inside the bucket. Next slide. We also can use a collaboratory notebook that allow us to extract information of any of the dataset. For example, we can extract from the MoviDig dataset all the dialogue of Speaker Rayleigh in movie 12 Monkeys with 20 or more turns per dialogue. Or we can check information, a specific information of, for example, just only MoviDig dataset. Next. So now I want to talk about the Microsoft Azure Cognitive Services script. We developed 3, the translate text. We translate from English to Spanish, and the translations are quite good, so we want to use in the future. Then we translate from English to Chinese, but the translations are not that good, so we discarded it. And also this script allows us to detect profanity terms in the translations. The second script is the text analytics that calculate the polarity in the utterance and also in all the sentences inside each utterance. So it provides a lot of good information. And finally, we have the content moderation script that detects profanity terms in the dataset and also the toxicity in each utterance. So it categorizes it in abusive, derogatory, or discriminatory language, as for example, sexual content, and give us a score of these categories. So combining all these scores, we can get a review recommendation that, I mean, if a human needs to revise these utterance because it may be considered as toxic. Next slide. So we use this model and compare it with a classifier that we have trained over more than 1 million utterances labeled with toxicity in a balanced way. So we extract random samples of 1,000 test terms of the daily dialogue, empathic dialogues, and topical chat datasets. And we run the Microsoft Azure Content Moderator and the classifier over these examples. We can see in the last line that the correlation of the result of these 2 models are over 80%, so it's a good result, both classified in a very good way. And I want to take a look at the right column where the toxicity detected. We think that 5% toxicity in each data set, and even more than 15%, depending of the model and the data set, is a very high value. So we have to take care about the toxicity in these data sets, and it's a very important problem that we want to highlight. Next slide. And finally, the lesson learned and future work. It's important to standardize the format and to pre-process all the datasets in the same way to increase the quality of further research. And as future work, we want to increase the number of datasets. As I said, we have 13, and the able features, now we have 20. We also want to train models with the Spanish translations, and then make a quality analysis of these models. And finally, we want to develop the fine-grained models to for detect toxicity and emotion and even ethical detection. And that's all. Thank you very much. And any question?
Tim Anderson, please.
Yeah, the toxicity is the. We can go to the slide. Uh, 84. Yeah. If any utterance has, for example, abusive content or derogatory, or, for example, bad words of profanity, that's a toxicity. Or bullying, for example, that is toxicity.
So we have I believe, a vocal question from Tim Anderson.
Yes, how is this configuration similar and different than Parlay and the Cornell dialogue toolkit or analysis kit?
Sorry, the configuration of?
How is this similar and different? There's a system called Parlay that has a lot of dialogue databases. They're text dialogue. And then there's also the Cornell dialogue analysis toolkit. Have you looked at those and looked at similarities and differences?
But you mean that why we didn't use it?
Yes, what's similar and different in terms of the formats, and are there things that you could leverage one way or the other?
If I could interfere, so the two things you mentioned, the Cornell work and Parlay, I think they're primarily text oriented. I know we've talked with the Parlay folks into kind of somehow introducing speech, but that's not going to happen for a bit. The purpose of this scheme is to actually be more general than those. I should also mention the Cornell work, which is very interesting, is actually focused on what to me is a different dimension of the problem that we're trying to address here. It's more towards sorry. Anyway, it's to me, it's kind of more. I don't want to use the word linguistic, but it's a more. It's literally looking at different level of phenomena. So I think we're in this sort of sweet spot that is responsive to the needs of the computational community.
Great, thank you.
Okay.